7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. These are the first 25 prime numbers. Prime number, as we all learned in elementary math classes, is a number whose only divisors are 1 and itself, e.g. 65,537. The ancient Egyptians and most of all humanity has studied prime numbers for however long we've been around. Now, the ones of you that aren't that big of a fan of math might ask, why the heck should I care about these, or what part do they play in my life? By the end of these 8 or so minutes, I hope I'll be able to give you a clear-cut answer. Also, by the end of these 8 minutes, you'll learn about a little bit of their history, their properties, and their modern applications. So we start with Euclid, who you might know from his geometry, which is a bit more fun than algebra. And he proved there was an infinite number of primes by something like this, where you have a list of prime numbers and you multiply them together adding 1. The answer is either going to be prime, which means you missed one, or if it's not prime, then there's still some prime number that's outside of that list. Like this thing. Then we move on to a German mathematician by the name of Bernhard Riemann, who in 1859 published his paper on the number of primes less than a given magnitude. And it was his only work on primes, but it contributed quite a lot to our knowledge today. And it involved this function, the zeta function, which is the sum of all the reciprocals of numbers. So 1 divided by 2 plus 1 over 3 plus 1 over 4, on and on. And he hypothesized that these zeros that exist on it, and for lack of a better word, he used complex numbers to create these zeros. He hypothesized that all of them exist on the line 1/2. And this is his prime counting function, which may look like a lot, but it's just us adding up all the non-trivial zeros, or ones that actually require effort to compute. And that function on the far right is you take the area underneath that, and those of you who are in calculus would get it. But anyways, then there's work by this man named James Maynard out of Oxford, who's worked with twin primes, which are really cool things that you can generate by taking, for example, 6 times, let's say 4 plus 1. There's a possibility that the two numbers that you can create are prime. In his papers, large gaps between primes have been his most significant contributions. And now we move on to modern day, where we have hackers. I'm more than willing to admit that I've had passwords stolen due to me using bad passwords. And we can start with RSA, which is raising a message to a very large power and then taking the remainder of it. You can undo this operation, but only if you have the prime factors of it, like you can see up there. And you know that little lock icon you'll find up in the corner of your browser, either green or black. That means that HTTPS is being used. And it uses a process sort of similar to paint mixing to make sure that attackers can't steal stuff, and that you're able to create a secure connection with a server. then we move on to some of my favorite things, large prime numbers. So, the largest prime number is not actually this, I couldn't find anything better, but the largest prime number has 24 million digits on it, which is actually 44 times the size of this PowerPoint when written out. And it roughly 6 times as many words as letters as a dictionary has. And testing for it is actually pretty easy. So much so that in the mid-1800s, the guy who came up with this test was able to find 2 to the power of 127 minus 1, which is around 40 digits, to be prime without a glorious calculator. And then they move on to factoring things. What it's doing right now is factoring out all the numbers with 2 as factors and 3, 5, 7, and everything left is then a prime. And this goes to massive numbers like this thing that was actually factored very recently, November 2019. And it was factored in 2 years, which is actually 3 times faster than the last one. So now I have no doubt that I've overwhelmed you with a lot of information, but hope I was able to enlighten you to the history of prime numbers, their cool properties, and their modern applications. Hope that this gives you better respect for early mathematicians and even more respect to the stuff that goes on behind the scenes to keep your stuff secure.